The American flag has 13 stripes and 50 stars. You know how I know that? Because Pocket Ronnie helped me with my numbers.
Okay, now we're going to be solving for x, and before we were just factoring. Now we're actually solving for x. So looking at 22b8, before in the last lesson, we would try to turn this base into the same base as this. If your bases are the same, then you can set your exponents equal to each other. But I can't turn 2 into a base of 3, and I can't turn 3 into a base of 2. So what do you do then? When your unknown is in the exponent, the best way to solve for x, to get it out of the exponent, is to take the natural log of both sides. In the world of algebra, it's legal as long as you do it to both sides. So if I take the natural log of this side, I have to take the natural log of this side. Okay? So basically what I'm going to do is take the natural log, and it's easier to use a natural log instead of log. You could do log, but on our calculators, we don't have, well, log. It's easier to do natural log in our calculators than the just regular log. So take the natural log of both sides. When you're dealing with natural log laws are the same as log laws, logarithm laws. What do you do with your exponents when you have the log or natural log? They get brought down in front. We can use the same laws. So our exponents get brought down in front. So this becomes 5 plus x times natural log of 2. This becomes 2 minus x times natural log of 3. Let me write these the same way. Okay, there are several different ways you can now solve for x. This just becomes an algebra problem. Natural log of 2 and natural log of 3 are just numbers. Okay, you can view that as a number. The book is going to leave it in the form of natural log of 2, but if you put it in your calculator, like natural log of 2 is, I'm just going to do two decimals, that would be 0.69. It's just a number. Natural log of 3 is 1.1, 1.0986, okay? It's just a number. So basically, what can you do with that? Remember, the idea of solving for x is to get x's on one side and numbers on the other side, okay? So, in other words, what I can do is I can distribute this. Again, there's several different ways to work it. I can distribute this to both things, okay? So this would be 5 times natural log of 2. Again, this just means 5 times 0.69. That's how you have to think of it in your brain. And then this is x times natural log of 2. Or if you want to say it the other way, yeah, I'd put the x out in front. Natural log of 2, so it doesn't look like natural log of 2x. That's too confusing. If you put the x in front, then you know that x is the variable. On this side, same thing. I'm going to distribute that. So that would be 2 natural log of 3 minus x natural log of 3. Now the idea is to get x's on one side and then your whole numbers on the other side, which these are numbers. So I'm going to add this over. I'm going to subtract this over. So basically I have x natural log of 2 plus x natural log of 3. Again, think of these as numbers. At this point, if you want to put them into a decimal, fine. Natural log of 2, in my brain that works easier for me. Natural log of 2, 0.693. X plus natural log of 3, 1.099x equals, I'm just going to write this out, 2 natural log of 3 minus 5 natural log of 2. Adding your x's together, that's 1.792x. I'm going to go ahead and subtract all this out. This is 2 times natural log of 3. So I'm doing the natural log of 3 first, multiplying it by 2. That came out to 2.197 minus natural log of 2 times 5, 3.466. Let's get over here. So that's 1.792x equals, subtracting those two things, comes out to a negative number, 1.269. Solving for x, divide that by both sides. Your book might actually be leaving some of this in natural log form, but you can put everything in a decimal form to see if your answer matches. So x equals, obviously it's going to be a negative, negative divided by positive. Comes out to a negative 0.708. There you go, solving for x. Okay, let's look at 22D9. Again, you're just going to hear me say the same pattern over and over. If your unknown is in the exponent, the best thing to do is to take the natural log of both sides. Okay? If you take the natural log of one side, you take the natural log of the other side, because that will get your unknown out of the exponent. So if I take the natural log of both sides, even though this has the natural log, basically what I'm doing is I'm taking the natural log of both sides. So this will be the natural log of the natural log of 2. Okay, so here, log and natural log laws say you can bring your exponent down in front. That is how your exponent, your unknown, gets out of the exponent. So that 3x can come down in front. So you have 3x natural log of e equals natural log of 2. Basically, this is just a number. Take the natural log of 2, which is, this will be natural log, and then the natural log of 2, just did that a second ago, 0.693. Then you take the natural log again. And that would be a negative 0.367. Over here on the left-hand side, 3x times natural log of e. Natural log of e is 1. Natural log of e equals 1. Write that over here. That's one of the laws. Natural log of e equals 1. I can prove that to you because when you have the word natural log here, what base is implied that we don't write? It's the base of e. And so to turn this into exponential form, you would say e to the 1 equals e. That is a true statement. E to the first is equal e. 2.718 to the first power is equal to 2.718. So I just proved that the natural log of e does equal 1. So anytime you come across natural log of e, it's always 1. So this is 3x times 1, which we can subtract 3x, solving for x, dividing both sides by 3. Negative divided by a positive is a negative. This would be negative 0.122. You can always check your answers by taking your x and putting it back up into the original problem, and both sides should come out to be a true statement. Okay, now we're doing 22b7. So whenever you can tell that you're going to factor, in this one we're going to factor, then you always want to set it equal to 0. So we're going to move the 3 over. That would be e to the x plus 2e to the negative x minus 3 equals 0. Okay, I can tell you, you don't want any negative exponents. Okay, so how do we get rid of that negative exponent? We are going to multiply every one of those by e to the x. Okay? I'm just writing this like this to say I am going to do, remember in the world of algebra, as long as you do it to every term, it's legal. I'm going to multiply every term by e to the x. e to the x times e to the x, what do? You add your exponent. That would become e to the 2x. E to the x times e to the negative x, add the exponents. Those cancel. You get plus 2e. When you add your exponents, e to the 0. What is anything to the 0 power? 1. So that becomes 2 times 1. Minus 3e to the x equals 0 times anything? 0. Okay, I'm going to rearrange this so that I am putting my exponents in descending order. Okay, now I want to factor. When we factored earlier, what we would do is make a substitution. We would say, let's let y equal e to the x. This way it's easier on our eyeballs. Okay, so everywhere we see e to the x, we're putting in y. Since this is e to the 2x, it would now become y squared minus 3y plus 2 equals 0. Okay, quadratic equation. How do you solve quadratic equations? First, you look to see if it will factor. If not, you use quadratic formula. This will factor. When this is a positive and this is a negative, we're not in a positive world. 2 ways you can get positive. Negative, a positive times a positive, and a negative times a negative. Since this is negative, they're both going to need to be negative. The only factors of 2 are 2 and 1. Make sure that when you FOIL it back out, you get a negative 3y in the middle. Okay? So, now what do? You set each one equal to 0. We can't just say y equals 2. You can't do that because we need to make the substitution back. Okay, we said we're going to let y equal e to the x. So we now have to go back and change every y to e to the x. Okay, so now this becomes e to the x minus 2 equals 0. This is e to the x minus 1 equals 0. We are solving for x. Okay. In algebra, you get x's on one side, whole numbers on the other side. So we're going to move our 2 to the other side. So we have e to the x equals positive 2. Over here we have e to the x equals positive 1. Since it was a quadratic equation, our highest exponent was a 2, we should have 2 solutions. This is how we're going to get our 2 solutions. How do we get the when our unknown is in the exponent, how do we get it out of the exponent? You take the natural log of both sides. So I can take the natural log of this side, natural log of that side. Same over here, take the natural log of both sides. Okay, when I do that, then by natural log and log rules, the exponent can come down in front. That's how it gets out of the exponent. So you have x times natural log of e equals natural log of 2. What is natural log of e? 1. So that's x times 1. So x equals natural log of 2. If you want to put it into a decimal form, you can get whatever the natural log of 2 is. I think that was 0.693. So x equals 0.693, and the book might be putting theirs into 4 decimal places. So that's one solution. Now coming over here, you can bring your x down in front. So you have x times natural log of e equals natural log of 1. What is natural log of e? 1. So that's 1. X equals natural log of 1. Natural log of 1 is 0. I can prove that to you because, so one of your solutions is 0. Natural log of 1 is 0. I can prove that to you. Natural log of 1 equals 0. What base is natural log in? There's a base e here that we don't write. If we want to put it in exponential form, we would say e to the 0 equals 1. Anything to the 0 power equals 1. That just proves that natural log of 1 does equal 0. So here are your 2 solutions for that problem.